Hey everyone, Katrina here. Welcome back. Today we're talking about integration by parts, part 2. Be sure to subscribe for more videos like this and watch to the end to see the example. Okay, so this is a very exciting part 2 of my integration by parts series. Be sure to check out part 1, my initial video where I talk about what integration by parts is. Today we'll be exploring a more challenging and multi-step example. So just as a little quick refresher, I'll let you know what integration by parts is. If you've seen part 1, be sure to skip to the example, which is linked in the description below. Okay, so integration by parts. This occurs when we have the integral of a function which is made out of the multiplication of two smaller functions. So that's the biggest thing. We basically have this multiplication between two parts of our function, which makes it more challenging to integrate. And essentially we're using integration by parts to break it apart. Okay, so what we have here is we have two functions, u and v, that are functions of x. We're going to label our u, and then we're going to go ahead and label the rest of the function, our v dx, as dv. And then using our integration by parts formula, we get that this integral equals uv minus the integral of v du, and this is still integrated with respect to x. So things to remember here is that this v is the integral of our dv, and then this du over here is the derivative of our u. Okay, and this here will help you go forward with integration by parts. Make sure to write this down. This will be your best friend on any math exam. And also be sure to subscribe for more cool tricks like this. Okay, so today we're going to do a multi-step example. Okay, so this is one step up from our previous video. So here, our example is going to be the integral of x squared multiplied by e to the power of x dx. So the first thing you have to do is recognize, is this a case where I can use integration by parts? Well, you're going to look. I have a multiplication, and the multiplication is separating two functions, both integrated with respect to x. Amazing. I can use integration by parts, and this is also, the short form is IBP. Okay, so let's go ahead and start labeling this. So we know that our x here is our u, and then we have that the rest of it, remember, is going to be our dv. So let's kind of start by writing a list here of all our variables that we need for our equation. So u is x squared. What about du? So what's the derivative of x squared? In this case, it's going to equal to 2x dx. So by having this dx here, that is just kind of making sure that you're taking the derivative with respect to x. And then on our other side here, we need to find v and dv. So dv we've already labeled as e to the power of x dx, and then what about our v? So the v is going to be the integral of our e to the x dx, and the nice thing about this is that the integral of e dx is e dx. So that's really exciting. So we don't have to do any more work there. We are good to go. So now from here, let's apply our handy integration by parts formula, which is uv minus the integral of v du. So before I said, oh, put your dx, in this case, we already incorporated it here. Just make sure that you remember that you're integrating with respect to x. So yeah, let's go ahead and just plug that in. So our u, we're going to get from here. So we've got x squared multiplied by v, which we're going to get from here, which is e dx, now minus the integral of v, which we already found was e to the x times u du. which is 2x and then dx, because we are integrating with respect to x. Okay, so let's see what we can do to simplify this. We can see in our second term over here, we have a 2. Following our integration rules, we can kick it out so that it's in front of our integral sign. So now we have minus 2 times the integral of e the x times x dx. Are we done? Wait a moment. We still have the multiplication between two different terms within our integral. In part 1 of this video series, after we did integration by parts once, we were good to go. However, what you have to notice here is that we have x to the power of 2. And because of that, when we take the derivative once, we only knock down one power of x. And as a result, after we take integration by parts, we still have that pesky x right over here. So what do we have to do? It's actually not that bad. All we have to do is apply integration by parts again. Yay! Well, all of us, we all know the drill now, so it's not going to be too bad. So we just have to apply the same kind of process again. So we have that our u here is e the x, and we've got that our dv is our x dx. But wait a second, is that what we did the first time? Not quite. We had that u was our x and dv was the e the x. I'm going to tell you right now that that's exactly how you want to do it, because that's going to be much easier going down the way. So we're going to switch the order, have this as x, and have this as e to the power of x. Your integral is still the same. It doesn't matter if you swap the order, because with multiplication, you're going to end with the same value. But the thing is, we want to make our u the part of our equation that is going to basically disappear after we take the derivative. What I mean by this is once we take du, the derivative of x equals to 1. So essentially it's going to go away. Whereas if we were to take the derivative of e to the power of x, the derivative is also e to the power of x. So we're just going to have to integrate by parts again and again and again if we keep doing it that way. So whenever you have x times e to the x, this is a trick. Make x your u and your e to the power of x dx your dv. And that will allow integration by parts to work its magic. Okay, so let's make a summary list. We have that u equals to x, du equals to 1 times dx, our dv equals e to the x dx, and we already said that v is the integral of dv, and we said that the integral of e to the power of x is simply e to the power of x. So now we're ready to apply our integration by parts formula again. Recall that it's uv minus the integral of v du. Okay, so let's make sure that we don't forget our whole beginning part over here. So we've still got x squared times e to the x minus 2, and then all in brackets here we have uv again, which is x times e to the x minus the integral of v e to the x du, which is 1 times dx or dx. Okay, so now this is looking pretty good to go. So we've got x squared e to the x, and then we can distribute this too, so minus 2 e to the let's actually wait a second before we distribute it, just so we can solve this integral first. So we've got minus 2, then in brackets e to the power of x, minus, well, what's the integral of e to the power of x? We already said that it stays the same, e to the x, and then we have to make sure we have our plus c value right at the end over there. Okay, so now that we have all of this kind of good to go, we want to make sure that we are distributing our values. So we have to take this minus 2 and then apply it to all of our terms within the bracket right over there. So by doing that, we get x squared e to the x minus 2x e to the x. And then these two minuses, we're going to have minus minus, which is going to turn into a plus. So we're going to end up with plus 2e to the x minus 2c. Since c is our integration constant, we can kind of just, to clean this up, we can pretty much just take this whole piece and say let c bar equals to minus 2c. That way, for our final answer, we have x squared e to the x minus 2x e to the x plus 2 e to the x plus c bar. And there you go. That is the final answer. So this showed us how, in some cases, especially when we have a non-linear value of x, a value that's greater, a value of x whose power is greater than 1, we actually have to apply integration by parts more than once. It doesn't make this problem any harder. It just takes a little bit longer because we have to apply it again, but you have all the tools and tricks that you need to find the answer. Definitely be sure to subscribe for more videos like this. If you enjoyed it, please drop a like and comment any questions that you have. I'll see you next time.